Swayam Prabha. Digital India. Educated India.
So, now there are many machine techniques available, right. So, it is very difficult to write a code for each one of them, right, and then check the performance, right. So, there is a common platform called the Veka. So, it is a platform which includes several machine learning techniques. Currently, it has more than 50 machine learning techniques including neural networks, support vector machines and clustering, right. Various methods are available in this Veka platform. So, you can use any of these techniques and it is easy to use it because you can choose it and you can see the performance, right, depending upon your problem, right. It will give you the different types of performance. I will explain how we use the Veka, right, machine learning workflow to classify these two types of proteins. For example, transmembrane helical proteins and the transmembrane strand proteins. So, he is developed the University of Hokkaido, that is in New Zealand. So, they developed long time ago. Right. Currently, they include various new features. When they originally initiated this Veka, they have only few features and their feature selection algorithm was not implemented and few machine learning techniques. Right. They tried to use it for some similar set of proteins. Right. Now, different instances and different sets of problems, right, they incorporated various algorithms plus the feature selections, right, the attributes. So, now it is having a full fledged the platform, right, for any classification as well as the real value prediction algorithms. So, they have different applications, right. You can see the explorer or experimenter, knowledge flow and the simple CLI. So, if we go with the explorer, right, then we can open a window, there you can manipulate, right, your data, give the input data and you can play around this Veka with the different machine learning techniques as well as your features, feature selection and the performance, right. Then first I will tell you how to prepare the input file. Right. Earlier in the previous version of the Veka, they accepted only the ARF format, right, and currently they also use this CSV file format, you can directly get from the Excel, right. Earlier days, if you have to prepare the input in such a way that there should be in a particular format type, that is ARF format, right. If you see the ARF format, first we give the relation, the @ symbol, give the relation, right, then you have to give the attributes. Here in this case now we use the composition. So, what are the attributes here? A combo 20 different amino acid residues, right. So, we have 20 different amino acid residues and we have to say what the type of this amino acid, you can, this is the numeric, right, and this is a different composition. Then what we have to do? So, that we have to explain. So, in the curly bracket we have to give, so we have to classify. Here the main aspect is TMH and TMS, right, this is alpha, this beta. So, they put class, we need to classify into alpha and beta, right. Then this is your properties or features what you have to provide. Then we have to give the data input, what is the values for your data set, right. So, let us start with that data, right, that data you have to start. So, here in the next line it starts with the data. So, what data we have to provide? First we have 20 attributes. So, 20 attributes or 20 compositions, this is the amino acid composition for the 20 residues, the same order. So, the order we give here, so we give the same order in all the proteins, right, and here this is output, because we know that this is alpha, if we know that we put the values alpha, if we do not know we can put a question mark, then that will assign, right. So, first we try to use a set of data what we have and see how it perform within the same data set and how to group into training and test and so on. So, in this case we take all the composition of all the TMH protein and TMS proteins, right, and here you prepare the input file with all the data. So, all data, right. Now, data set is done. So, this is the ARF format, you have this is the attributes, this is the class and this is the instead of data points. So, now what to do? So, if you click the explorer, then this will open a file, this window, then here various options. So, first is we need to pre-process the data, right, that means we need to input the data, right. So, we have to open file. So, if we click on the open file, right, this will ask where we need to get the data. So, this is your computer, right, then this is the location of this file, right, this is in ARF format, right. So, if you click on open, you can open the file, right. If you click this one, then you will get this data, right. Here if you see the left side, right, you have the under the name you can see the 20 alphabets, right. These are 20 amino acid residues, because these are the 20 input values give for each protein. Then 21 we give the class. What is it class?
Category.
This is alpha or beta or TMH or TMS, right. So, now you can see the count, right. If you have the data set, we have 3000 alpha plus about 400 beta. When you get the redundancy, remove the redundancy, we get non redundant sequences. Now, how many helices and how many strands? 612 helices, right, and beta is 97. So, TMH is 612 and TMS this is 97, right. This is the data size. So, these are the instances, right. You can visualize the instances seq12 helix and 97 TMS, right. You can read the data. Now, the next question is, right, you have to choose the algorithm, the features we gave, right, input the problem we set, we collected the features, we gave the features, now we need to choose a method. So, various methods available in the Weka platform. So, broadly they classify and base are the functions, are the meta servers and the rules, trees and so on. Under the base there are the naive Bayes, base net and so on. If you go with the functions, right, they will get the different logistic regression and other aspects, like likewise you can see the neural networks, multi-layer perceptrons. So, you can get various support vector machines, right, under the various options. We will have more than 50 programs, right, they are incorporated in this Weka platform. So, you can try various options and you can see the performance. Now, we have the input data, we chose the input data and we have the functions, right, we chose the functions, that is also fine. So, now we have to start, right. So, here the default option is 0R, right, because this is the option given in Weka platform, right. But if you want to choose, you have to click on choose, then if you click on this choose, it will list all the techniques and you can expand any of these major classes and you can select the which option do you want, right. If you want the support vector machines, you can use the support vector machines, right. If you click the start, right, this will give you this result. For example, if you take the support vector machines, okay, it will give this is the SMO, right. So, these are the default values they used in the support vector machines, right, the different parameters. I will show you now different default parameters, right, fine. So, now here there are various options available in this Weka platform. Here we use this use training set, right, this is the use training set, right. What is the meaning of use training set?
Self assessment.
Yeah, you can, if you give how many data we gave?
600 plus.
Right, we gave 612 plus 97, right, 612 plus 97, this will be 709, right. So, take all the 709 data for training, it will give you the data, right, they will give you the final result, right. Then if you have the supply test set, that means you can train the Weka, right, for with any learning technique, for example, support vector machines, right, with respect to this 709 data, and if you have new data set, for example, another 50 data. So, you can give it as a test set, a supply test set. If you click on supply test set, this will be open and then this will be enabled, right. So, then you can click on this set, right, this will ask for the new data set and from your computer terminal you can give the new file. So, this will use that file as your test set. Then the third option is a cross validation, the tenfold cross validation. For example, what is tenfold cross validation? Right, you can use the out of 709 they classify into 10 groups, right, then use the 90% as a training and the 10 as a test set. So, do it for 10 times, finally give the values. So, take the 10% out here, 10% out here for the testing and do it to 10 times, right. So, now if you here if you give the 10, so they give the 10-fold cross validation. Then also there is another option called percentage split. Here you can see how much percentage you want to use for training and for the test, right. So, the default is 66. This is why if you see many papers they use a 66% split, because they do not change this, just use the default values. This you can change if you want to have the say 80% or 70%, right. So, here they mention 66 because 2/3, this is why they put 66. So, you can change this percentage split and you can try to evaluate the performance method, right. Fine. So, when you do the cross validation and start click, so you can this is the start button, if you click it will give the data. Out of this 709, so 693 are correctly predicted, right. So, the percentage accuracy is 97.7%, right, and the error is 16 are wrongly predicted. So, the error rate is 2.25%. Now, this method is good, right, that is fine. Okay, then can we see only the accuracy? No, but we have to check the sensitivity and specificity, right, because it is the unbiased this is the not the same data set. You can see the different types of levels of data, the 612 for the helix and the 97 for the strand, it is not equally distributed, fine. So, in this case you can see the true positive rate, this for the alpha, this is for the TMS H and this for the TMS. So, this will give you your sensitivity and specificity. For the case of the TMH, this is 987 and the 91.8. So, if you take the average weighted average, right, this is 97%, right, that is fine. So, always you have the other information regarding the false positive rate, precision, recall, F measure, ROC, right. So, ROC is 0.95. So, how the graph looks like? Very high, right, look like the straight line, right, because this is very high, 0.95. So, in this case your area under the curve, right, that is very high. So, the method is reliable, right, you can do that. So, you can see the confusion matrix, right, this is the confusion matrix. What is the meaning of confusion matrix? Yeah, it can give you true positives, true negatives, false positives and false negatives. If TMH is positive, what is the meaning of true positives? TMH predicted as TMH, right, this is the true positive, right, you can see this confusion matrix, right. So, this is true positive, right, you can see this is the true negative, right. So, this is the false negative and this is the false positive. So, if you see this one, then you can get the sensitivity, right, true positive 603 divided by total positives, right, this is the 702, right. So, in this case this is the sensitivity, right, this is here in this case only 87. So, this specificity is less, right. This also I discussed the one of the issues with the machine learning, right. So, you can see this is highly trained with this positive data set. But in this case it is also good that the negative data set is also properly trained, because the specificity is also 91.8, right. In this case it is fine, good. So, this is the formula to calculate the sensitivity, specificity and accuracy. You can calculate sensitivity by true positive by the true positive plus false negative, specificity is true negative by false positive plus false true negative, and the accuracy is total positives with the all number of data, right. So, all number of data, this is the correctly predicted data. So, number of correctly predicted data, right, you can see that. So, now if you want to see, okay, here what is the main, what are features we used here? Amino acid composition. How many compositions we used? 20 compositions, with 20 amino acid residues, we have 20 compositions. Now, the question is whether we need all the 20 amino acid composition to get these values, because as I discussed earlier, right, we should minimize the features, right, for any classifications, right, even the QSR also we discussed, right, we should minimize these features, right, in case you can reliability will be high, right, error will be high, error will be less, right. So, in this case we see whether the composition of all the residues are necessary, or we can eliminate some of the amino acids. If some amino acid residues, if they do not make any change, then we can eliminate this amino acids, you can reduce this number of features. So, in this case we eliminate one amino acid and see whether using other 19 amino acids the performance is similar or any change. If there is any change or similar one, then you can discard. If it drastically reduced the performance, then that feature is very important, you need to keep. Likewise, you can do all the 20, you can do one by one, remove one amino acid and then see which amino acids are not very important for classification, right. Then you will have 19. First if you remove 1 or 2, then you have less, then again you try the other one. So, again among 19 you can try to eliminate 1. So, by reducing these features you can optimize the features, manually you can do that, but in Veka there is also another option, it will also automatically select the features, but in any way if you get to less number of features you can also try, right, manually doing all these things, so you can optimize the features. That is one way. Second one, we can use only one amino acid, say just alanine. What is the performance of alanine, where 50% or it is 80-20% or 70-30%, and doing all these 20 features you know the important features which one have the highest performance. Then you combine these features and also you can enhance the performance, right, to say the highest performance with reduced number of features, right. This is will be helpful for the reducing the number of features. So, in Veka also we have the attribute evaluator, right, we can manually do that, or you can use the Veka, you can see the attribute select, right. This perform the feature selection to identify the best set of features, right. If you do this, this will also give you an option, okay, these are the probable features which can give the best performance, right. So, for in this case each attribute selection algorithm, right, is effective with specific classifier. So, for each classifier they use different algorithms to optimize these features. For example, if you take a support vector machines, right, they use the SVM attribute evaluator, right, this is here, right, to optimize these different features, right. If you do this, right, so there is various options, right, you can give that. So, here you can see, right, this is option, this is the SVM attribute evaluator, right. So, what are the various capabilities, right, for example, the complexity parameters or the different types of filtering, right, now how to normalize the training data and so on. Then for the classifier also we have various options, right, we can use these different file types or what are the different kernels we want, right. Here we use the poly kernel type, right. Also you can see all the details, right, in the Veka platform. So, for any machine learning algorithm you use, you have to first check what are the various features available. For example, if you use the neural networks, you can assign your hidden layers, right. So, all these information they set a default value, right, trained with some normal data, but with respect to your data set, fine tuning these default parameters you can improve the performance, right, not just relying the default parameters given in Veka. If you fine tune the parameters, right, you can improve the performance at least 3 to 5%. So, now you can see the test set that I discussed earlier, how to get the test set. So, here this is the supply testers if you give, right, you click on the set, right, then it will open this box will open, right. So, in this case open file here, right. So, you can give the file, right, and then the supply test set you can get the data, right. So, now here this is the data set for the test set. In this case we use the same the features, these are the composition we used, right, 20 amino acid residues, the same class. Data if you see the here, if you do not know the test set you can put the question mark. The question mark means the prediction is unknown. So, in this case the Veka will predict whether it is helix or strand. If it is known alpha or beta, it can also evaluate this is the positive or negative, right, it is correctly predicted, it is wrongly predicted. This is the output. So, it is also possible to list the output predictions. For example, here there are various evaluation options. You can give output model, or you can output the confusion matrix, and also you can put the output predictions. If you click on this output predictions, for each case this will give you the data. What is the probability of the particular protein to be in TMH or in TMS? For test data it will give the probability, and based on probability it will decide. If you know the data, it will tell the probability for TMS and TMH, and then see is positive or it is error. Okay, I will show the data, right, here this is the case. So, which is this the we do not know, it is a question mark. So, this is the predicted as 2, right, this is the beta. For example, if you see the probability is 0 for TMH and probability is 1 for the TMS. So, this is beta. Second case the probability is 1 for the TMH, so it is predicted as alpha. Third one is also 1, this for alpha, right. Sometimes we get the different numbers, not 1 and 0. 0.6, 0.7 in the decimal also will get. Based on the higher values it will classify either alpha or beta. So, if this is this is already known, this is alpha, right. In this case this is predicted as alpha, right, then it is fine. If it is known as beta, this is 1, this is predicted as alpha, this is wrong. If it is wrong, it is mentioned as plus here. In this case, if you want to see the plus signs here, wherever you have the plus signs, these are wrongly predicted. For example, in this case this is alpha is actual case, but the predicted case one is in the second case beta, so it is predicted as beta, so it is wrong, so put the plus sign. In this case this is alpha, with this number this is 1 is here, so predicted as alpha, so that is fine, right. Finally, you can get the final data. This case the classification performance is 57%, is good, is not good. So, in this case we need to go back, the training set you need to change the features. For example, you can include the hydrophobicity as one of the features, you can from this knowledge you can add more features and use the training, use the cross validation and use the test, right. If you are able to predict, then it is fine, otherwise you need to work on these features and you need to manipulate the giving the feature selections, and finally as long as you are convinced, right, you need to train this machine learning to get the highest performance. So, in summarizing, so what did we discuss in this class? The applications, right, for example, classifying transformed helical and transformed beta valent proteins, mainly with the statistical methods as well as the machine learning techniques. For statistical methods, we can compare the composition of the standard set, right. For this we need to develop a data set and they calculate the composition, right, and compare with the unknown ones, and based on the deviation obtained from the Hamming distance or the Euclidean distance, and you can decide. Then you may use some error function to decide what is the error function which gives the best performance, right. Then go with the machine learning. What are the different types of machine learning we discussed? Supervised and supervised learning. What are the example for supervised learning? Neural network and support vector machines. For the unsupervised learning, k-means clustering, right. So, different types of machine learning techniques. Then we discussed about the Veka. What is Veka? It is a platform, right, which contains different types of machine learning techniques, right. You can use machine learning techniques, right, as well as the feature selection algorithm, right. You can merge in the Veka platform, right. So, for example, if you want to use Veka, so we need to prepare the input files. What are the accepted input files? Which formats? ARFF plus CSV, right, you can use it. So, how to prepare ARFF file? First give the attributes, then give the values and then the class, then finally give the data, right, then this will give. So, what are the various options available in Veka for the evaluation? You can use training set or the cross validation or the split sampling, also you can use the external set, right. When we run the Veka, it will give you the confusion matrix. What is the meaning of the confusion matrix? True positives, true negatives, false positives and false negatives, right. Using this confusion matrix you can calculate sensitivity, specificity and accuracy. Also Veka directly you can get the values, right, along with the precision as well as the ROC and all, right. So, now you can use this information, right, to use to predict, right, or to discriminate or any different classes of these proteins, right. Also here we have the attribute selection algorithms. This will also select the preferred attributes to give the best performance. So, there are various applications in Veka. If you see the literature, there are a lot of papers they published using Veka software, right. Also another important thing is, instead of using the default parameters set in Veka for any programs, support vector machines or neural networks, you can change the default parameters and see, right. So, then how they change the performance, right, you can improve the performance at least 3 to 5%, right, fine. So, there are plenty of applications, some of them we discussed in the last class. So, all these applications, right, we can use the Veka platform and select the best machine learning techniques, right, to achieve the highest performance. So, in the next class I will summarize all the different techniques or the algorithms or the concepts we learned in the past several classes, right. I will summarize the all the information, right, in the next class. Thanks for your kind attention.